Hi, in this video, we're going to take a look at word frequency analysis. For this example, we're going to take Dungeons and Dragons Adventure League adventures that are available through dmsguild.com. Okay, so I'm a mathematician. I am a true nerd. I am a nerd's nerd. I like Dungeons and Dragons and mathematics. So we're going to dig into this. I hope you find this interesting. All right, so whenever I'm doing a text analytics project, after I do my data prep, I'm going to take my text, I'm going to clean my text. Did that in a previous video. I'm going to look in the simplest format of what do I have in my documents. Just, what number of characters, number of words, what are the most common characters, what are the most common words, and things like that. And the reason why I do this is just so I get a feel for what I'm working with. In a lot of ways, this is like univariate analysis for a more complicated statistical project. I do simple analysis so I get deep so I get some understanding of what I'm working with. Then when I get into the deeper analysis, I've got more of an understanding to handle things and dig in. All right. So the dmsguild.com is where I got these. These are Adventure League adventures, for like going to a convention and playing. So let's go ahead and start looking at code. So something I always do when I start out on my code, I always set digits to 3 because I don't want the whole long decimals printed out. I want to keep it short and sweet, round it off. And then I want to avoid scientific notation as much as possible. Clear my workspace of any artifacts that's floating around. I love piping, and so even though percentage, caret percentage is not a pipe, I will use the McGritter package, and I'm going to be using visualizations from ggplot2. Normally, I try to avoid using the library function. I try to use double colon notation, but with piping, I definitely need McGritter. And with ggplot, I use so many different of those functions that I might as well just load the whole package. Not loading packages can prevent problems down the road. Okay. All right. So when I load my data here, I've already gone through, I've cleaned it up, and I have everything set up at the page level. So when I read the PDFs in the previous video to convert the text into data, the like R really supported getting pages. That was a natural way to do it. That basically said, hey, each unit of text in a document is at the page level. So I went ahead and just kept it exactly like that. Um, and in that data set, I've got a collection of character and numeric variables. And I'm going to go ahead and get rid of anything that is a blank. So if there's a blank page in there, and there are in the data set, I just want to go ahead and get rid of those. And so if you check out what I've got for the data set, the first column is the name of the adventure, which tier it is, which is 1, 2, 3, or 4, which is a bucket of the player character level. The campaign, and here it's coded as 1, 2, 3, or 4. So like Tyranny of Dragons is campaign 01. Which adventure it is in the campaign here, this is 01, 02, 03, like that. And here is the title, which was extracted from the document. The page number that we're talking about within the adventure, within the campaign. Here is the word count of the original, the original text before cleaning. And then we've got the character count of the original, the word count of the cleaned version, the character count of the clean version, the original text, and the clean text. Now, something that you'll notice is I purposely put the text to the far right. If I have special characters that will screw up, like opening things up in Excel, like I want to take a look at what I'm working with, special characters in the original text column can break up the cells in Excel and make it so that if, let's say, original text was far left, I can screw up all the column alignments. Any special characters that are in here won't mess up the alignment of the columns to the left of them. But in general, we don't want to be using Excel, but a lot of times that's just like the quickest, easiest way to start looking at my data if I need to get better understanding what's going on. All right, so what I'm going to do is show how we can aggregate across different different groupings that we have. All right, so I've got a document for each one. So my data set is at the individual page within adventure, within campaign, and so then also each adventure falls within a tier. And so we have this nesting structure to it. And so what I can do is, what, maybe I don't want things at the page level. Maybe I want to analyze at the adventure level or the campaign level or maybe the tier level. I'm going to focus on the tier level for this video because that's the simplest one. I only have 4 different levels on there. The visualizations are simplest. For my project at work, I might have to do things a little bit different. So I'm going to go through and I'm going to do this at the document level. So what I want to do for each individual adventure, I want to go in and I want to take all of the pages and put them into one long text field. So I have each row is a page of corresponds to a page of text. What I want to do, I want to concatenate all of those pages into the original document format. All right. And so, well, what's some things I'm going to want to know is like, how many pages did I have? All right. Well, that's just going to be the maximum of the page numbers. What was the original word count that I have across the entire document? So I'm doing a summation of the word count across the pages. And then I want to know how many characters do we have in the entire document. Once again, I'm doing a summation. We want to know like how many words are in the document and how many words are in the clean version of the document text. All right, and so the original text, I'm just going to concatenate them together. In Python, I can just do a plus symbol, but here I'm using the paste function. And then the clean text, I'm doing the same thing. All right, so let's go ahead and take a look at what I've got. Now, I'm not going to show the actual text because it's so long, it's going to make it difficult to see. But now, each row corresponds to a different document in Adventure League. This one's actually not an adventure. It's a document supporting an adventure, but conceptually you can see what's going on. So here I can see, all right, so there is this particular adventure, which is Dreams of Red Wizards 2. This one's going to be tier 4. The campaign is DRW. Here is which adventure it is. And here is the title of the adventure, which I pulled from there. I have the number of pages and the word count. And then also I could go in and check out the rest of this. All right, well, let's do this again, but now instead of by document, let's do it by tier. Let's say I wanted to analyze the text in these adventure by tier, so that way I could get a feel for what's different for the players to encounter or for a dungeon master to have to prepare for differently. All right, so now I'm going to group by tier, and I'm going to play the same game, but now you'll notice that I'm going to have, here I've got my document. So every document is in a tier. So I have a nesting structure. So I'm not using my original data set. My original data set is at the page level. Now I have things at the document level. Well, you know what I can do? I can go ahead and take advantage of that. And so I'm going to group my documents by their tier, the column right there. And then, the sum of the pages gives me a number of pages. Here I'm going to be adding up the number of words, adding up the number of characters, and repeat that for the clean version. And once again, I'm concatenating. So here, these 2 columns are going to correspond to text for the entire tier. So every single level 1 tier adventure is going to have text inside this column. And so, the one particular cell is actually going to have all Adventure League level 1 text in that one cell. It's going to be a long cell. And here's going to be the clean up version. And so this is actually going to have a 4-row data set. And so we can take a look at it. And so here we can see the number of pages for all tier 1, number of pages for all tier 2, number of pages for all tier 3, number of pages for all tier 4. And so something that we can see very quickly is that in terms of pages, tier 2 has the most pages. Oh, okay. Um, my overall assessment is tier two tends to be the most popular because there the players can do some stuff. They're not as vulnerable as tier one. Uh, and there's like a good amount of stuff to work with as an author and as a dungeon master, but it's not too complicated. If you ever like get into like a tier four game, the rules of Dungeons and Dragons slow things down by a lot. And that slowing down really sets it up so that it's really not that much fun, honestly. And so tier three, tier four, if you don't have an experienced group that's like really on the ball on making things flow quickly, it's not that much fun. But tier two, that's like the sweet spot in my opinion. And other people agree with me for sure, or we wouldn't have so many tier two adventures. Okay, so now that's going by tier. So this would give me an idea of like what's like this row of data. If I analyze the text, gives me an idea of what I would experience as either a player or a dungeon master playing a tier two campaign or adventure. All right, well, another nesting that we have is by campaign, and I can play the same game over and over and over. However, I want to analyze the coarser grouping of my documents. And so here we can see for each of the campaigns, the number of pages, number of words in the original version, number of words in the cleaned up version. And so like just looking through here, we can see that Dreams of Red Wizards has a lot of pages to them. And there's a good number of adventures in that one, which is kind of interesting. It's mostly higher level adventures compared to the rest. Now let's take a look at the number of words per page. All right, so here I've got a histogram of the number of words per page, and we see a spike here for a very few words on a page, which is so this is probably going to correspond to like appendices, title pages, pages that don't really have a lot of text that are more for like being organized. Also, like the maps that are presented in the adventure are going to be farther to the left. And so we can see, somewhere around 750-ish, we can see is the most common number of words per page. Now, this is the original version. This is before I cleaned it up. Something that we'll want to take a look at after I clean my data is like how much of a change was there from cleaning my data? So notice that the scale here, goes, comes up, so the five, so this is less than 1,500. And so, we're, let's say about 1,200 is like a maximum. Well, when I look here, I can see that, wow, it's like the words were cut in half. Remember, I got rid of single letter words. I got rid of stop words. I got rid of numbers. I did a lot of cleaning to clean up this text. And so this gives me an idea of how many words were actually removed when I did my data cleaning on this. Also, if we want to, we can use the color aspect to get an idea of the distribution of tier. This really is not the best visualization for analyzing word counts by tier. I would rather do a subplots with faucet, grid faucet wrap for that. But here we can at least just get an idea. But notice that it's the tier four. I don't have as sharp of a spike as I do elsewhere, like in tier two. All right, so let's take a look at the number of clean words by the number of original words. And you can see that it's a pretty good, linear regression line. It's pretty solid. Of course, it doesn't fit linear regression perfectly, but definitely a strong relationship going on. And so this just gives me an idea of how many words were removed when I cleaned up the text. Now, number of characters per page, same game here, but now I'm looking at individual characters, and this will include a white space. So if I have just a regular old space in there, like between two words, that counts as a one. So here we can see that we have much larger numbers, but we see the same shape, which really is not surprising. And then boom, we get, a similar shape and a similar result of a drastic reduction, but much larger than the number of words per page. And once again, I can do the linear regression thing. This looks a little bit tighter than the previous to my eyes, but it's not, it's pretty close. All right, so now let's go ahead and unnest my token. So I want to look at the individual words. Okay, and so when I do this, I'm going to take the original data that I have. I'm going to unnest the tokens. I want individual words. Here, I'm taking the individual words of the clean version, not the original. I've already converted things to lowercase, so I don't need to convert to lowercase. And I don't want to drop anything. And so here, and I always like to have things as a data frame. And then I'm going to go ahead and run the count function to count by each word. And then let's go ahead and sort it. And let's look at the most common 20 words. All right, so character, adventure, hit, damage, attack, creature, the abbreviation for feat. So on the map, it's a 5-foot square. It is the standard saving throw, target, difficulty, challenge, spell, make, point, player, throw, action, check, level, turn, party are my most common words. So character, that's interesting that character is almost twice as common as the second most common words. Huh. All right, so let's go ahead and do a bar plot of this to visually see it. And so we can see, how prominent character is on here. Now let's look at the words by the tier. All right, so I'm going to play the same game, and I'm going to take a look at the most common 10 words by each of the tiers. So I'm taking the top 10 words, and I'm going to go. Okay, let me show the code, make sure that you can see what's going on. All right, so I'm going to take the words I have. I'm going to limit it to just the tier and the clean text. I'm going to unnest the tokens like I just did. Then I'm going to filter it out so only the top 10 words. I'm going to group by tier, group by word. I'm going to count the number of times that each word appears in each tier. And then I'm going to order the words by their frequency. So I'm taking the count. So here I've got a count for tier 1, count for tier 2, 3, and 4 for each word. All right. Well, for my visualization, I want to order the words by most common to least common. And so what I'm going to do, I'm just going to add how frequently each word appears in each tier, and then I'm going to order the words correspondingly. And then I'll arrange everything out so it's nice and easy. And so now this is what I've got. So I've got for each tier, each word combination, I have the count. I have the words are in order from most frequent to least frequent overall. And now I'm going to do my visualization. And once again, I'm using ggplot. I'm going to use geom_call because I've already done the calculation. I use geom_call anytime that I've already computed, I already know the Y value. If I use geom_bar, I'm going to be using that when I want ggplot to do the calculation for me. And always, always, always label what you've got going on. I like to put smack dab in the middle of the bar. And I'm going to do a coordinate flip. That way, I set it up so that the word is nice and easy to read. Look at that. Isn't that nice? If I wouldn't have done coordinate flip, then the words would have been like in a vertical position at the bottom, kind of hard to read. This is much easier. I find that stakeholders at work prefer this. All right. And so we can just see what's the distribution of the most common words for each of these. I did let the scales change. The main reason for that is because tier 2 is far more common and tier 4 is the least common. So, because of that, I wanted to be able to zoom in and look at things proportionally. And so tier 1, we definitely see more of a curvature, corresponding to how it was originally than tier 2. But when I look at 3 and 4, things look a little bit, like more, closer to like more, more choppy. And so we can see that like adventure appears disproportionately less often than what we would have expected for tier 3 and tier 4. Kind of interesting. Save is more common in tier 3 and tier 4 than we would have anticipated. So, I'm getting an insight into what's going on for whatever my future analysis is going to be. All right, so now this is a trick that I've done at work that has been very successful for me. What I want to do, I want to find the words that are specialized to different subgroups. All right, and so I'm going to use tiers once again, just because it's easy peasy lemon squeezy. And uh, so how am I going to find words that are more specialized to different tiers than others? Well, what I'm going to do is I'm going to do a chi-square test. I'm going to take tier and word count, and I'm going to run a chi-square test. Now, I don't really care about the hypothesis test. What I care about are the residuals. I'm going to take the standardized residuals, and whenever a standardized residual is large and positive, that means that that word happens more frequently than expected compared to the entire population. Okay, and so what I'm going to do, I'm going to take that chi-square test, standardized residuals, positive values, the largest ones, means that, hey, this word appears more frequently than we would have expected. And then we're going to run our analysis. So I'm going to take my tier and my word in the unnested format. So I have each time a word appears in my clean text, there is a row for that in this data frame right here. And then I'm going to just do the counting. I've got the table. All right, now what I'm going to do, I'm going to take the table. I'm going to pass it to chi-squared test. And then I'm going to pluck the 9th slot. All right, I don't like this code because I'm saying the number of the slot. I have trouble getting standard. STDRES is the name of the slot. That's actually what I wanted. For some reason, I had trouble with the htest format of the object, but this went ahead and ran for me, so I did it. Convert it to a data frame. I'm going to call, so something that happens with this at this step in the process, because this is a table object, when it gets converted to a data frame, okay, actually, I forgot to say something. So I've got a table, and I put it into chi-square test. I take the 9 slots, and the output from here is in a table format. But it's actually a state, it's not a frequency, it's not a count, it's the standardized residuals from chi-squared. Okay, so what I do here on the next step, that data frame, that's going to convert that table from wide format to long. And so then I'm going to have for every single tier, every single word, I'm going to have what is the standardized residuals. So it's going to be a 3-column data frame. All right. And the residuals are going to be called frequency. And that's just by default what R does. All right. When we pass the table to as.data frame, I use this trick a lot at work, by the way. And so frequency doesn't really make sense. So I'm going to convert it over to residual so I remember what it is. It makes sense to me. Probably could have called it standardized residual. Might have been a little bit better. I'm going to drop the frequency column. It's just, so if this was a big data problem, this would not be efficient code, but it's a small enough data set, it doesn't matter. I should have really renamed the column. Now I'm going to arrange things by residual, and I'm going to take the top 10 of there, and then I'm going to go and just take a look at what do I got. Shadow Dusk, Tazam. These I believe are like gods or high-level demons in the Dungeons and Dragons world. Hecaton is a giant, I believe. Then Vampire, Soulmonger, and Obsidian and Rift. I would not have expected that. So Tazam makes sense. That definitely makes sense because that is a high level villain. That's like the ultra uber super villain. He is such a high villain that in the Dungeons and Dragons movie, he appears, but he is not directly involved because he has an underling, Sophia, doing his dirty work. Hecaton is a god, so it's probably like a tier 4, or maybe the Giants campaign is appearing. Then vampire. All right. So with vampire, the reason why this is appearing in a different manner than we would expect across different tiers is because of Curse of Strahd. The Curse of Strahd campaign, vampire appears a lot. It has a very specific tiers to it. So those tiers are going to have vampire more frequently. All right, so I've got my table of unnested tokens. I'm putting it as a data frame. I'm going to get rid of any time I have a frequency of 0. So here I'm working with the counts now. This identifies which ones I want to take it into it. I want to do an analysis of. Now I'm going to take, hey, what are the actual counts of each of these words in my in the actual data? And so here, if a word does not appear in a tier, if I didn't do this step, then my visualization would have a bar of 0 height. And I find that just kind of like, crowds things, makes it, it doesn't really help the interpretation of the visualization, especially when real estate is very valuable on your plot. I'm going to go in and I'm going to reorder my words from most frequent to least frequent once again for the visualization. And then I'm going to use ggwordcloud just like I did before. And so now for tier 1, we can see boom, vampire. That tier 1 has the term vampire more often than we would have expected compared to the other tiers. Tier 4 almost never has the word vampire. Tier 3 and 2 definitely have vampires running around also. Now, something I found very surprising is that here the words that are the most specialized that we have are tier 4 words. Look at this: Tazam, Hecaton, Rift, Obsidian, Yongu, Shauda, Soulmonger, and Zifiu are all appearing in tier 4, but not so much elsewhere. Tazam appears in tier 2, or actually appears in all of them, but twice in all of tier 1. Has some representation in tier 2. It's getting talked about, but then boom, look at that. 250 over 250 times for Tazam. So now that makes sense though, because he's such a high level villain. All right, so now these bar plots are how I feel like you should actually present your counts and your frequencies. This is more informative. It's easier to interpret. People will get it right more often with bar plots than with other techniques. But my experience is that people like word cloud. So in every text analytics project I'm working on, I include a word cloud. Word clouds feel more informative than they really are, but for some reason, stakeholders just like them, so I include it. So I'm going to do a word cloud. I'm going to be using ggwordcloud for this. And I'm just going to go through, I'm going to do this for each tier. Originally, I had a faucet grid where I had all 4 on one visualization. It was too small, not enough real estate. So we're going to zoom in on each individual tier. And I'm just going to go in and I'm going to look at one tier at a time, tier 1, 2, 3, or 4. I'm only going to work with tier in the word that I've got from the unnested tokens. Then I'm going to do my count. Oh, I'm not even going to consider words that are less frequent than 4. And then I'm going to arrange by the count. And then I'm going to limit it to the top 100 words for each tier that's within the individual tier. I'm going to change. I'm going to color. So I firmly believe that for visualizations, most of the time you want discrete colors. You shouldn't have a continuum. Continuum feels more informative than it really is. And so I'm just going to color with 3 different colors, and then I just like having everything nice and arranged in a nice, easy manner. A big data problem, I would not be using the arrange function. And then I'm going to do my word cloud, where I've got the label is the word, the size is the count, and the color is the bin of the count. So approximately a third of the words will be blue, a third will be green, a third will be red. And the word cloud sets it up so that the most frequent words appear towards the middle, which we can see with this. That's tier one, tier two, tier three, and tier four. So let's see, is there anything interesting that I can spot with this? All right, so I noticed the word poison for tier three. That's actually a higher level than I would have anticipated. Oh, tier two, that's poison. Does it appear anywhere else? I don't see it, but I am moving relatively fast. So, that's kind of interesting that like tier one and tier four looks like they don't really have poisons, for the players to have to like, deal with as a threat. All right. I hope you enjoy this video. That's all I've got for you. Life is short. Do math.